Alright, so we're going to go over the following circuit. We have to find V1 and V2. Let's write some direction of current. So let's call this I1, I2. 3 amps is going into the V2, so okay. And then let's call this I3. Okay, so let's write the nodal equation for V1. It's I1 that's leaving and it's equal to I3 that's entering. And then for node V2, it's I3 is leaving and I2 is leaving. And this is equal to 3 amps that's entering. Now let's find an equation to represent I's. So I1 will be equal to V1 minus 0 because the current goes to the low potential, which is 0 volts, which is the ground node. So minus 0 all over 8. I2, it's V2 minus 0 all over 4. Now I3 is a tricky part because there's this there's this voltage source that's in the way. So what we're going to do is we're going to try and find the voltage at this point. So we know that since the current is leaving from the positive terminal, the voltage at this point is going to increase by 2 volts from where it originally was. So at this point, it'll be V2 plus 2. And then it continues going. So V2 minus V1, which is a low potential, all over the resistor. So this will be equal to V2 plus 2 minus V1 all over 2. Okay, now let's plug everything into our equations. So I1, it's V1 over 8 equal to I3, which is V2 plus 2 minus V1 all over 2. Then for node V2, it's V2 plus 2 minus V1 all over 2 plus I2, which is V2 over 4 equals 3. Alright, let's times both sides by 2 here so I can get rid of this 2 at the bottom. So this and this cancels out, and this becomes 2 over 8, which is 1 over 4. There you go. That looks much more easier to work with. And same with here. Let's times both sides by 4. So this is 4 over 2. So 4 over 2 is just 2. And since we're timing this side with 4 as well, it'll just be V2. And then 4 times 3, that's 12. Alright, so this looks much more neater. So now we have V1 over 4 equals V2 plus 2 minus V1. And this one we have, let's FOIL the 2 one. So it will be 2V2 plus 4 minus 2V1 plus V2 equals 12. Let's collect like terms. There's only one V1. There's two V2s. Okay, so it's minus 2V1, 2V2 plus 1V2. That's 3V2. And let's bring the 4 to the other side. So it goes from 4 to minus 4. So it will be 12 minus 4, which is 8. Alright. So, and this one, let's bring the V1 to the other side so we can isolate it. So let's bring it up here. So we have V1 over 4 equals V2 plus 2 minus V1. Let's bring the V1 to the other side. So it'll be plus V1 here. Then let's combine them. So it'll be 1 plus 1 over 4, which is 1.25 V1. Let me double check that. And yeah, okay. Now let's divide both sides by 1.25. So it'll be here. That's what V1 is going to be equal to, and let's plug it into this equation. So minus 2, V2 plus 2, all over 1.25, plus 3, V2 equals 8. Alright, so let's FOIL the minus 2 in. Minus 2 V2 minus 4, all over 1.25, plus 3 V2 equals 8. Let's break this up. So minus 2 divided by 1.25. That's minus 1.6 V2 minus 4 divided by 1.25 minus 3.2 plus 3 V2 equals 8. Let's bring this to the other side. So it's 8 plus 3.2, which is 11.2. And let's add these two up. So it'll be minus 1.6 plus 3, which is 1.4 V2. Divide both sides by 1.4, and you get the following. You get 8. Now we solve for V2. Now let's find V1. Recall V1 was equal to this. So it will be 8 plus 2 all over 1.25. So it's equal to 8 plus 2 divided by 1.25, and that's 8. So these are your final answers.